1.288 volts.
Minus
1.288.
1.288.
288.
Is it others? Others? Are you getting the same answer? The output voltage?
Yes, ma'am.
Okay. Moving on. The next question.
Ma'am, can you explain how to calculate the output voltage?
Yes, ma'am. Please
Output
explain.
voltage is in here. In order to find the output voltage, apply the KVL with respect to the parallel branch. Here, silicon along with you have 20 ohm resistance. Correct? So what you have to do is apply the KVL from with respect to ground level. This is ground, right? Negative. Okay, with respect to ground, bottom to up, that is bottom to top approach, apply KVL. So what you will get is 20, how much is the resistance value? Yeah, 20 ohms. 20 into IB, the current flowing through that path, plus 0.7 volts. How much you'll get? Like this only you have applied, right?
No, ma'am. I took the main
Wait,
current,
wait,
which
wait,
is
wait,
the
wait,
total
wait. I
current.
made a mistake. Just a sec. Wait, wait, wait. No, total current you can't. Okay, you took total current. How total current will come
Yes.
into picture? With
Yeah, by
respect to
mistake
that
I
path,
took
IB
it.
is flowing through this circuit.
Yeah, by
Huh?
mistake I took it.
With respect to that particular path, IB is flowing, correct? So consider only IB. So it is 0.7, then plus 20 into IB. If you do, you'll get the output voltage. So here the drop is 0.7, which is connected to positive of the diode. Here the drop is plus 20 into I. Guys, are you understanding? Or if you go from bottom to top, if you can apply the KVL from bottom to top, you'll get minus 20 into, plus 20 into IB plus 0.7. That is what I have done. Apply the KVL from bottom to top. Okay. What is the drop over here? You calculate. What is the drop over here? You calculate.
Ma'am, will the answer be 0.995 volts?
Yes, ma'am. 0.994.
How much?
0.99.
0.995.
0.99 volts, is it?
Yes,
Yes.
ma'am.
Is this the answer? Even others are getting the same answer?
Yes, ma'am.
Yes, ma'am.
1.
0.99 volts.
Yes, ma'am. 0.99 volts.
Next. Okay. Next question. Guys, please mute yourself. I'm getting lots of disturbances. Okay. Next question. So this is the given circuit. This is 2.5K. This is 1.5 volts. This is silicon diode. This is also silicon diode. Okay, make a note of the circuit. They're asking you to find the current which is flowing through this path, main current. Are you able to see this one?
Yes, ma'am.
I and V naught. This is the given question. So how do you proceed now? Even this is also a parallel circuit. You'll have to find loop currents. With respect to this main current type, you have 6 volts like this, means the loop current IA flows like this. Okay, loop current IB flows like this. Initially, we will assume both the diodes which are present in the circuit are as forward biased. Diodes are forward biased. By getting the current value, if current value is negative, the total current which is flowing through the silicon diode, the main current type, if it is negative, then we will consider the diode as reverse biased. If it is positive, then we will consider the diode as forward biased. Did you understand?
Yes,
I
ma'am.
shall repeat once again. I shall repeat again. So here what happens is they're asking you to find the main current I which is flowing through the middle path, and then to find the output voltage V naught. Okay. And you don't know whether the diode is forward biased or reverse biased. So initially what we will do, we'll assume both the diodes as forward biased. Okay. So first step is you'll have to find the loop current, loop A, loop B, find the currents, and then you sum up both the current values in order to find the main current I. So now the main current I, whether that is positive or negative, that we'll have to find. If it is negative, then that diode happens to be reverse biased. If that current value is positive, then the diode is forward biased. If the diode is reverse biased, then you have to show the circuit as open circuit. Those things and all we will see later. First you solve now. Later we will come to know. So apply KVL, loop 1 and loop 2. Find IA, find IB. Tell me these values. Apply KVL.
Ma'am, IA is 2 milliamp.
IA is 2 milliampere and IB is 1 milliampere.
IA is 2 milliamperes. IB is 1 milliamperes. Okay. So how do you find I based on the loop direction? It is IA minus IB, correct? No? Guys, please respond. If you perform IA minus IB, you'll get the current I. Is it?
Yes, ma'am.
So how much you'll get? That will be it is positive. So therefore, diodes are forward biased. Okay, this you have to check whether the diodes are forward biased or no. Now you find the output voltage. In order to find the output voltage, what you have to do is you have to consider this path now. Only this path. Across this, you will find the output voltage. Okay. So therefore, apply the KVL from bottom to top, from ground level to top. So therefore, it is minus 1.5 volts plus 2.5K multiplied by IB. If you do, you'll get the output voltage. So here the drop is minus 1.5 volts. You are getting right. Here the drop is minus 1.5 volts and here the drop is 2.5K into respective current, loop current. Understood? So find the output voltage.
Is it 1 volt? Ma'am?
Correct. Answer is 1 volts.
Yes, ma'am. 1 volt.
Others, are you getting?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, next question.
Mom, why is it minus 1.5 V?
Omisha, can you tell me what is the drop over here? I am applying the KVL from bottom to top in order to find the output voltage. With respect to the polarity, what is the drop over here? You are able to see the cursor here?
Yeah. Yes, ma'am.
Huh? I have placed the cursor over here.
Yes, ma'am.
I shall change the color. Are you able to see the cursor now?
Yes, ma'am.
What is the drop over here? I am
Uh,
applying KVL from bottom to top. Okay.
okay.
So what is the drop over here? Minus
Minus
1.5. What is the drop over here?
2.5.
What is the
Yes.
drop over here?
Plus 2.5.
Omisha?
Yes, ma'am. Hello.
Omisha, are you there?
Yes, ma'am. Ma'am, am I audible?
Okay. Here the drop is 1.5. Here the drop is 2.5 K into IB.
Yes, ma'am.
That is the reason. That is how I have written the KVL equation.
Okay, ma'am.
Okay. Question here is to find the current I flowing through this particular diode and to find the output voltage V naught. Similar to previous question. Please solve this. Initially, we will assume both the diodes to be forward biased. Find the loop currents.
IA is 0.5 milliamp.
Correct.
IB is 0.34 milliamp, ma'am.
No, please check once again.
And it's 0.34 only.
Okay. Just a second. You are getting 0.34, is it?
34.
Okay, we'll do one thing. This is not 2.3. This is 2.5K. Make a correction. This resistance is 2.5K. Tell me IB value.
Ma'am, 1
And
milliamp.
0.3.
Huh?
1 milliamp.
1 milliamperes, correct. It is 1 milliamperes.
Yes,
Others?
ma'am, 1 milliamp.
Okay. So what is main current now? Main current is IA minus IB. Correct, no? So 0.5 milliamperes minus IB is 1 milliamperes. So main current, what you will get? You will get negative value of current.
Yes, ma'am.
Okay. Now please listen here. Yes, all of you please listen here. Later you can write. So you calculated the loop currents IA and IB and you found out the main current I is IA minus IB. Okay. So after doing all those things, you will get the main current value negative. Correct. Once you get the main current value negative, it means that the diode is
Reverse biased.
Reverse bias.
okay.
Reverse bias.
Diode is a reverse biased. The main current which is flowing through that particular diode is reverse biased. If I consider, say this is D1 and D2, okay. So I'll call diode D1 is reverse biased. Did you understand? So if the diode is reverse biased, now what you have to do is you'll have to rewrite the circuit considering the reverse bias. So how are you going to rewrite the circuit? Rewriting the circuit in the sense you'll have to show that particular diode as open switch. Okay. And then you rewrite the circuit and then you calculate the output voltage. So here this is open. This path is open. Did you get? Guys, are you there?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
this is make
Yes,
this
ma'am.
open. Make this open because it is reverse biased. And then you find the output voltage. Okay, before finding the output voltage, you have to find the new value of current. I knew. We made the diode open. Find the new value of current. Yes, guys, tell me what is I new value?
Mm, 0.6 milliampere.
Yeah,
Ma'am,
0.61. 0.6 milliamperes. Did you get this?
Yes, ma'am.
Okay, once you have calculated I new, find the output voltage with respect to this new current. Guys, is it over? How do you find the output voltage? It is minus 1.5 plus 2.5K multiplied by I nu. What is the answer?
Zero 0.025 volt.
0.
Yes, ma'am. 0.
Is this the answer?
0.025.
0.025.
25,
Ma'am,
is it?
it will be 0.025.
0.025.
Okay, fine. So is it clear? Any doubts in today's class?
No, ma'am.
No, ma'am.
No, ma'am.
Okay. Shall we continue tomorrow?
Yes, ma'am.
Yes.
Yes.
Yes, ma'am.
Okay. Yeah.
Yes, ma'am.
So please go through whatever we have done, solve all the numericals once again. Those who have doubts with respect to KVL, please solve each questions, all the questions solve one more time. Once, twice, if you solve automatically, no, the polarity and those values and all, please don't do mistakes. We have seen in the test paper, kilo, milli, micro, mega, nano, those, there only majority students will go wrong. So please be careful, and along with that polarity, please be careful while considering the polarity sign for each of the circuit element. Okay? Yes. We'll continue tomorrow. Yeah. Thank you, guys.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Yeah, tell me. Someone is calling.
Ma'am.